Hello, whoa, and yeah, finally welcome back to Python and welcome back to Matplotlib and back to 3D plotting. And yeah, got really sick last days, that's why I didn't record anything. Feeling still sick, but yeah, needed to do something to kill the time, so yeah, let's head to more 3D plotting. And because it's a long time ago, let's repeat the elemental steps of the 3D plotting. First we need plt, not that, plt point figure. We have to declare an object, x equals plt point axis, projection, it's an argument, projection equals 3D, written in lowercase of course. And yeah, let's simply say plt point show. Let's run it. And yeah, here we go, our 3D, here we get our 3D map. We even know that. And yeah, by declaring, let's say, two numpy arrays, I mean 3 numpy arrays, because we have 3 axes. We need, yeah, 3, for a simple graph, we need 3 one-dimensional arrays, numpy arrays, plt point show. Yeah, I had to look up for the function, it was plot 3D, taking at least 3 arguments, which are the axes. And if we run our code, one second. By the way, I got it wrong. It is not plt point plot 3D, it is x point plot 3D. Now if we run, you can see our graph, which is 3-dimensional. Taking a little turn here on, what is it? Yeah, x like 1.5, 0.5, something like this. It's hard to catch it because it's 3D. But yeah, that's for the reminder. Now let's do something different. Let's create a little surface. For that we are changing the dimension of our numpy array z, adding, upgrading it to a 2-dimensional array. And the function we are using now is plot surface. And yeah, let's run it. And now we got a little surface. We have 3 rectangles, not 3, 2 rectangles. I'm still sick and not able to count properly. But yeah, we can create surfaces, and of course more elements of our arrays make them more complex, being even able to kind of simulate certain terrains or even models. So you can think for yourself, what do we need if we want to create a really simple square, for example. You can pause the video and think for yourself. I'm doing one, if I can remind it correctly. Because as a quick reminder, if you're confused, we get, these are coordinates, 1, 2, 0, 2, 1, 1, and so on. So for example, if we have 0, 0, 1, 1, let's do only, let's do less elements. And let's run it. We got our, square. But square is boring. Let's create a rectangle, or let's create a object in the shape of a rectangle, of a roof of a house, a rectangle roof of a house. And you should always delete this. Oh no, you should delete this commas anyway. But let's add another element for each of our arrays. Now we already had 0, 0, 1, 1. Let's have 0, 1. And yeah, our z-axis containing only zeros and ones, and this is a float. We wanted 2 elements, not a float. Here we go. We already have 2 of them. So let's add another one. And again, you can think for yourself which coordinates are needed for the third part. We want to create here a rectangle, like it's already another line from 0 here to 1. No, from 1 here to 0. I hope you get what I mean. Pause the video and yeah, let's do it now. It's pretty simple. Just another 0. Because he needs to draw back to our 0, 0 coordinate. And for that, just another 0. Here we go, we have our little roof. And you can create a lot of objects, but can be quite fun to experiment with it. And you can spinning. Could even do art contests with it. Depends on you, but So let's move on. Of course we can do kind of messed up stuff with that again. And p point random point rand gets us an array with 100 floating point numbers from 0 to 1, if I remember correctly. P point array. Let's do it. Oh, I'm totally stupid. I mean, and p point random point rand. For the shape, let's do it like this. Kind of really messed up, looking like collection of shards, because we have 100 different coordinates. So let's do something like sorted. Let's try out what will happen now. This is, you can try different functions, of course, because he's kind of sorting each one. The output looks a little bit what means I wanted to say more structured, but this doesn't look structured, but you have to be honest, it looks slightly different. Now that still looks a little bit boring, so let's try something else. Because you can do pretty fun stuff regarding colors, so let's change the coloration a little bit. We are doing that with the cmap argument. cmap equals, now we use plt point get cmap hot. And you can even think for yourself, the output is now consisting of colors from yellow, red to kind of black. And orange, of course, which is between yellow and red. Kind of reading the surface, and surfaces that are more on the top got yellow. Here you can see surfaces that are mostly on the bottom got black. But let's unsort them, because got kind of in that case I guess it looks a little bit more interesting if we don't use here we can see it even better. The ones which are more at the bottom are got blacker, and on the top it gets hotter. If you want, you can also, if I remember correctly, you can also add 2 dimensions to the x-axis. Doesn't change that much, but now they have to be also linked with the 2 dimensions of the x-axis. Same goes for the y-axis. 1 second. we go. Let's return. Yeah. But yeah, in my opinion, just looks overloaded. But yeah, there are many cases where this can be useful. But yeah, looks a little bit too overloaded, in my opinion. But like I'm repeating myself, kind of know a few scenarios where this can be helpful. And yeah, already hit the 12-minute mark, or no, 11-minute mark, but regardless, let's say goodbye, see you in the next video, have a nice evening, dinner time, night time, whatever time it is in your country, and I don't have any outtakes today, I'm sorry. See you and bye bye.